So we're going to first graph these two lines from their equations and determine um, where they intersect. So we're going to start with -2 is the y-intercept. So I'm going to go down here to -2 and put a dot. And we can see that the growth rate is 3 over 1. So up 3 over 1, up 3 over 1. Okay, we're going to draw our line here. Take the ruler, line this up here. Okay, then we'll graph the green line now. And again, we're going to start with the y-intercept, which is 13. So I'm going to put a point up here. Let me roll this down so I can get to that 13 there. Put a point. And then this is -2, so it's down 2 over 1, down 2, down 2 over 1, which puts us here. So now we'll draw a line and get the ruler out. Our lovely digital ruler here. And now we can see where they cross. We can see our point of intersection is right here. And we're going to write that as a coordinate pair. So that's 3, 7. Now that we've done that, we can also prove this algebraically. So we're going to move over here. That a little smaller. We're going to move that over here where we can see our graph and our equation. And because this is just an equation like any other, I'm going to draw a line on the equals because it's just solving an equation. And the first thing I'm going to do is I'm going to put my x's together. So I'm going to use a positive 2x here with this negative 2x. So I can make a 0 pair. And I'm going to add the 2x on this side. And that gives me 5x on the left minus 2 equals, that was a 0 pair, so just the 13 is left. Now, again, I want to work to isolate that x, so I'm going to move the negative 2 away. I do that by doing the opposite, so positive 2. Did it on one side, so I do it on the other. This makes a 0 pair. So when I complete this, I have 5x equals 15. And now, because I don't want 5x's, I want 1x, I'm going to divide by 5. 5 over 5 gives me a 1. I divide by 5 on this side, and now I just have 1x left. And that x equals 3. Now, I have found x, but I need to find y. So, I'm going to go right over here. I'm going to take my original equation. My original equation y equals 3x minus 2, but I don't want x. I now have a number or a value for x of 3. So I'm going to substitute that. Now I have y equals 9 minus 2, y equals 7. I have one more equation. So I'm going to do that one. Y equals negative 2x plus 13. Except wait, I have a value for x now. So I'm going to substitute that. I solved x to equal 3, so I'm going to put a 3 in there. And then I'm just going to keep going. So now y equals negative 6 plus 13, so y equals 7. This is the same as this. So this must be accurate. Therefore, the place where these cross is 3, 7. And we can see that because this comes from here, this, and this go there, and it's the same thing we have here. So two different ways to find the point of intersection or where lines are the same.